Thank you for joining us for the second session of our Water Talk speaker series. Our guest speaker is Dr. Jude Benavides. Dr. Benavides has a PhD and a Master of Science in Environmental Science and Engineering from Rice University, as well as a Bachelor's of Science in Civil Engineering from the University of Notre Dame. Dr. Benavides has 15 years of academic experience with hydrology and water resources. He's also an associate professor with a tenure at UT Brownsville for 13 years. 20 years in environmental engineering consulting, and 12 years as a U.S. Naval Officer. His research and specialization is in flood alert systems, floodplain mapping, water quality monitoring, and water resource analysis in the Lower Rio Grande Valley. Without further ado, Dr. Benavides.
Can everybody hear me okay? Let's see if, can everybody hear me? If I'm probably supposed to speak into this thing, so let me see if I can pick this out, because I like to walk around. Okay, good afternoon. Thanks everybody for coming out. I didn't know how many people to expect. This is actually the first time I've ever given a presentation in front of my kids. So there's a different kind of nervousness there going on. I'm usually like, well, whatever, it's going to be okay. Anyway. I'm here to talk a little bit about water, and I was really excited to hear about this. I've heard about the Smithsonian traveling exhibit, and I had never really had an opportunity to see what it was about. When I was approached by Tara to give a talk, my answer was, yeah, absolutely. How much are you going to pay me? And I said, yeah, absolutely. I'd love to be able to talk about this. And so today, one of the more difficult things when I'm given half an hour, 40 minutes, something like that, to talk about water. Water is one of my passions. I'm from Brownsville originally. I grew up on a resaca. Actually, not right away. When I was 5, my parents bought their greenhouse on Edgewater Street here in Brownsville, off of Price Road. And so, moving to a place with a water body in the backyard when I was 5 was the dream come true. Canoeing, jumping in the water, and falling in the water is more like it. Fishing and spending time with my parents and friends on a waterway was eye-opening to me. And getting to explore the resaca and go to some of the islands, the little islands were there, and a lot of undeveloped properties at the time and exploring. I felt a little bit like Tom Sawyer. And so the resacas have always had a kind of a place in my heart because I spent my formative years on one, literally on one, and fishing in one. And it's actually, I grew up right here. Okay. And they actually dug those lakes out of the natural resacas. And so those lakes are about 6 or 7 feet deep, sometimes 9 or 10 feet deep in this area here. And exploring those was a lot of fun. Then I left for 18 years. I went to University of Notre Dame. I was an officer in the Navy for 6 years active and another 7 years reserve. Finished up as a lieutenant commander. And after my active year stint, I came back to Texas to go to Rice University, where I got my master's and my PhD. And I met my lovely future wife at the time and convinced her to move down to Brownsville. She's from Michigan. And she's been working as an environmental engineer here since 2004 now, going on almost 20 years. And I've been at the university, well, the college, university, college, university, whatever its new name is lately. But right now it's UTRGV Brownsville campus. So I've maintained my employment there. And I'm heading up for full professor next year, I hope. And part of my job is to talk at events like this and explain, share a little bit about the knowledge that I have built up over time and learned a little bit about different things. So let's start here. Everybody know what a watershed is? If you don't, right back there's an excellent exhibit about what this is. And what watershed do we live in right here? If you live in the Brownsville or Harlingen or McAllen area. I'm sorry, the Lower Rio Grande watershed, right. Some might say the Rio Grande watershed, but we don't. We don't live in the Rio Grande watershed, and actually, we are just, even here, we're outside, technically, outside of that watershed. And the reason why we'll talk about here in a bit, and I don't mean that to say, ha, you're wrong, or whatever. It's an important consideration because our stormwater runs off and doesn't go to the river. our stormwater that goes to these storm sewers actually goes to the Lower Rio Grande Valley through the Brownsville Ship Channel. And so it does impact directly fish and ecotourism opportunities that we literally spend time in, okay? That we fish in, swim in, and drive over if you go to the beach. Hopefully at least on a semi-regular basis, you have the opportunity to be out there. But a watershed is nothing more than an area of land. Rainfall that occurs in that area drains to a common outlet, okay? It's our geographic accounting unit. As a hydrologist, this is what we use as our bank account. This is our water account, okay? The hydrologic cycle replenishes water through rainfall, and that surface water does run off. If it doesn't get into the ground, and even if it does, it's likely to pop up later, bless you. If it doesn't evaporate and go away, which a lot of it will up here, it's going to work its way down these various tributaries, like the Rio Salado, Pesqueria, San Juan, the Conchos, and notably the Pecos and the Devil's River, which I just wrote a couple of chapters on here, and hopefully getting published, well, will be published next year in the Rivers of North America encyclopedia. The water will flow out and pass down between Brownsville and Matamoros. And of course, I'm not a rocket scientist. I like studying things that make sense. And let's not forget that the boundaries here, these borders, are not political. They are dictated by topography. And don't forget the basic truism of hydrology that water flows downhill. It also flows uphill, did you know that? Water flows uphill towards the money. Okay? That's about as good as the jokes get, folks. You're not laughing. All right. So, I said we didn't live in the Rio Grande River Basin, and we don't. We actually live in the larger basin right here. It's called the Nueces Rio Grande. And the reason why it's called the Nueces Rio Grande is the intercoastal, inter-riverine. It's the coastal basin between the Nueces, okay, and the Rio Grande. This is not my slide. This is from the Texas Water Development Board. I almost said the Toxic Water Development Board. Texas Water Development Board. Freudian slip. And you can see these coastal watersheds here, 7, 11, 13, 15, 17, 20, and 22 are in between these larger river basins. And I want to point something out to you. I'm actually going to walk up to the screen. Notice how all of these river basins, okay, whether it be the Brazos or the Colorado in this case, or the Trinity, they all come down to a very narrow neck. Okay? Why is that? Anyone know? What makes all of these watersheds everywhere around the world come down to a narrow neck? The mouth of the river has something to do with it. The base sea level. The water doesn't have a direction to go. It doesn't necessarily know which way to go. It's going to start to back up and flood out of its banks. Whenever there's a lot of water flowing down, there's going to be a lot of bank flooding, out of bank flooding here. And what that's going to do is going to deposit sediment as well as water along either bank of the river.
Is it because of sediment in here?
Absolutely. And that deposited sediment literally forms what we call natural levees. Natural levees. And these natural levees form, they're not human-made levees. They're natural levees. These natural levees then prevent water that is raining in between and landing here from actually flowing into the river. Because this land right here, this boundary line right here between 21 and 22 is actually higher than either side of it. And that's a key distinction. It's really important to understand when it comes to, as hydrologists, and today as waterways, we need to fundamentally better understand and do a better job of explaining. We understand it pretty well, but we need to do a better job of explaining, all right, to folks who live in this area, that we aren't flat. If we were flat, everybody would flood equally. And we know that's not the case. It doesn't take a Mount Everest to dictate which way water goes. It doesn't take a mountain chain to explain or force water one way or the other. All it takes is a beer can. Okay? All it takes is some bit of elevation. Because the water molecule we're talking about is very small. And water can be directed by the smallest of things, particularly if it's slow moving like it is by the time it gets down here. So that's a key distinction I want you to keep in your mind as we go along this discussion. Not understanding that. What are the implications of that? Well, they can be far reaching. They can be, hey, I don't live in a valley because there's no mountains. Whoever said a valley needs to have mountains? This is a river valley. In fact, that was the first term for valleys, was river valleys, not mountain valleys. We do live in a river valley. It's plain as day if you look at the LiDAR, and I'll show you that here in a bit. So this is the inter-riverine coastal basin we live in. Okay? Anybody know what the western boundary is over here in Jim Hall County and it splits Starr County? No, the sand sheet is, yeah, that's a good point. The sand sheet is all right in here. The Bordas escarpment right in here. Okay, there's actually an escarpment. There is a small, I'm going to say hill range, but it's about 1,000 feet up, almost 1,000 feet, just right here. Okay? Now, you're not going to notice it. It's very gradual. You will notice it. You'll notice it going up. But it's not like you see this huge 1,000-foot range. Okay? And that escarpment, okay, is the boundary line between the rivers basin and the Nueces Rio Grande Basin. The rest of that, a big portion of it, you're right, is the King Range. A sand sheet in here, and this is why we don't see any rivers. This is why this is the biggest intercoastal or inter-riverine coastal basin, because this used to be the bottom of the Gulf of Mexico about 25,000 years ago. This was in the Gulf of Mexico, or the same water body that the Gulf of Mexico is today. It deposited a lot of sand deposit right here. And you see that sand when you drive up through Kingsville and through the past the checkpoint. So, narrowing in, we can always subdivide a watershed into sub-watersheds and sub-sub-watersheds and so forth and so on. But we always call them watersheds. You can get really, really small. And with advanced technologies, we can start to, even in flat terrains or flatter terrains, we can start to analyze and visualize where water will go under certain conditions. Three of the watersheds we have here is the Rio Grande, which is the white area just between the blue river line and either the pink or the green. No disrespect to Mexico, I'll show them here in a picture here in a second. But for right now, focusing on the U.S., we've got the Arroyo, Colorado, we've got the Brownsville Resaca coastal watersheds, or the Lower Rio Grande Valley Brownsville Ship Channel watershed. Oops. There you go. That drains, and you see a boundary here between them. Now remember what I told you about boundaries between watersheds are higher than the areas to either side of it. So what would this mean right here about a resaca? It's elevated. Very good. Absolutely. This land here is higher than this land here or this land here. How can that be? How can a river, doesn't a river downcut? Doesn't water drain to a river? What's different in this area, here, and down here as well, but it's not shown in this map, than even the Arroyo, Colorado, and other rivers? The big difference is that this is a delta. This was formed by river water flooding up and out of the banks, remember? Depositing sediment and soil outside of its banks, reforming the landscape not through downcutting, but through elevating. And we'll see that. Now, I'm not saying the resaca bottoms are higher. Of course, water is going to go to a low space. But you're going to see that the natural levees of rivers are present also in resacas. And that matters significantly for where water flows and how our waterways, whether they're archaic, meaning several thousand years old, or modern day channels that we dig, function.
I have a question.
Yes, ma'am.
So then how did you detect that boundary?
I'll show you here in a second. With technology called LiDAR, light detection and ranging. Okay, more modern day topographic. It's like super radar. Okay, we'll talk about that in a second. And this matters because these boundaries, these watershed boundaries, determine our waterways. Because the waterways are, if the watershed is the body, the waterways are the arteries flowing through it. Okay, and collecting and or depositing. And in this case, the Arroyo outlets right here into the Lower Rio Grande Valley. All of these areas work their ways through different channels, okay, into the Brownsville Ship Channel now. And that deposits or flows into the Lower Rio Grande Valley. Only this area here and or water that we forcefully pump over the natural levee
the human-made levee, and now through this wall that we have built, okay, will make it back to the river. And that's a natural process, exception of the human-made levee that makes it even higher, okay? But that's a natural process. These are some lines, some blue lines that signify waterways. This is actually from a national hydrography data set at a very large scale. It looks pretty complex, right? A lot of different waterways flowing, perhaps not all of them flowing, many of them stagnant in some cases because there's not a lot of water. I'll talk about the resacas here in a second. But that's only half the picture. That's not even half the picture. It's probably like 5% of the picture. If we add the next one, oops, I ruined my surprise. If we add the next one, we start to interlace some of the main drainage ditches and main irrigation canals into this system. And you can see just how complex this starts to become. This isn't even the arterials. To liken this, these darker blue lines are like the interstates for water. These lighter blue lines are like smaller highways and our main city roads. And then we throw in all the arterial and neighborhood roads. These are all waterways. Irrigation ditches, canals, resacas, rivers, arroyos, you name it. These are actually defined waterways in the hydrography data set, meaning that through remote sensing and on-the-ground visual verifications, we have, at one point or another, water in those lines. Yes? Oh, I thought somebody had a question. You can see how complex this is. Now add the fact that while we're not flat, we certainly don't have a large slope, and pretend you're a water molecule and that has to decide which way to go. You got a lot of options. Now try to model it computationally. That's not easy.
Jude,
Yes?
and our streets are also waterways.
Absolutely. I'll get to that. Yep.
They're the smallest ones, right?
Yeah, they're the smallest one by necessity. Absolutely. By design, we'll talk about. Yeah, absolutely. Out of necessity, because if they're not in the streets, it's in here. Yep. Yep. And now it shouldn't stay in the streets forever, but that's another point. So let's take a look at an aerial photo. Let's not forget our friends to the south, okay? So here's the Rio Grande River, obviously the U.S. side of the coast and the Mexican side of the coast, but there's some similarities here. Look at this bulge. That bulge is the delta. And you can see some similarities. There's a Lower Laguna Madre here, and there's a Laguna Madre down here in Mexico as well. There's a barrier island that was created from the exact same types of sediment and sand transport that these levees, natural levees, were created from. We see a lot of little smaller bays in these areas, sometimes with little elevated hills on the northwest side of this flat terrain, of this water body. Anyone know what those linear elevated areas are called? Lomas. Yeah, lomas, clay dunes, okay? If you drive out to SpaceX and along Highway 4, and this isn't SpaceX's fault, I don't want to get into that topic. All right, the road was built on top of lomas because those were elevated. They didn't have to spend a lot of money elevating the road. And every now and then you go down for a little bit and you notice there's very different flora in the upland, which is just 25 feet up, but that's Mount Everest in this area, and 2 feet above the coast. You see all of these features here. Well, let's overlay what we have identified now as researchers at UTRGV, the ancient and now partially abandoned waterways, and or completely abandoned waterways. I really should show this in green, or if I had an invisible color, right, doesn't make any sense, right? Because this does not mean they're flowing. All of the resacas are now ancient, naturally disconnected from the river because of its natural levee. But all of these were at one point or another an ancient river path, meaning from 10, 15,000 years ago to a few hundred years ago. And some of these we're starting to identify as older. It's very hard to identify using traditional carbon dating methods, okay, because we don't have a lot of rocks in this area, and there's not a lot of datable carbon present that we can look at easily, but we're using other methods. And that gets a little technical, but we can see even through, just go on Google Earth tonight and zoom in around these areas. And if you look carefully, you will see history's story, the river story interlaced in the ground. you will see a darker curve all of a sudden in the middle of a farm field or an irrigated field, and followed by another curve. And you're just like, what is that? That is the old riverbed. It's now flat because its natural levee is so old and it's been dry for so long that it's gotten rained on and eroded and blown by the wind and blown away.
That's before we dammed it.
Yes, well, if this ever happens again, we're,
Before we.
before we started messing with, and controlling the Bravo behind the Rio Bravo. Absolutely, absolutely. But now introduce that same network that I introduced on the US side to the Mexican side. And you can see, with the exception of these lines which highlight the coastal bay boundaries, you can see a very distinct kind of break between the human-made straight lines and those boundaries, those curvy lines. That right there, folks, right there, okay, is the modern-day Holocene edge of our delta, okay? And we have cut through it, okay? Meaning the last 25 to 50,000 years, okay? This land is not very old. This is relatively new land. It is very, very rich soil, okay? Sometimes salinated, sometimes overused, and sometimes parched. But we have interlaced the waterways of this area with artificial waterways to a tremendous benefit and to, unfortunately, significant impact. Zooming in on Brownsville, Los Fresnos, Laguna Vista, South Padre, San Benito, and Harlingen are the 5 major resaca systems here, okay? And there are 5 of them. Starting from north to south, de Los Fresnos, okay, which drains or flows historically through San Benito and kind of breaks up because it is the oldest, okay? Resaca de los Cuates, which actually flows through the town of Los Fresnos, because this region right here was Los Fresnos. All right, and so the town of Los Fresnos is named after this region, okay? And through Bayview. This is one of the larger resacas. The big resaca system is Rancho Viejo, which you can see actually breaking away from the river here, a true distributary, the opposite of a tributary. Tribute is to contribute, tributary is to contribute, distribute. Distributary, where the river now flows away from itself and out and forms a triangle shape that we call a delta. Point, point, point. There's your triangle, the Greek letter delta. So looking at these 5 colors, we continue with Rancho Viejo, which actually does spend most of its time through and around Brownsville. It does pass through the city of Rancho Viejo, okay? Resaca de la Guerra or de la Palma, both are used interchangeably. And then town resaca, the one we have just down the street, right here. A quick note. Anybody who knows me, my students in particular, know that when somebody says a resaca is an oxbow, they get my attention, okay? Because they're not just oxbows. Oxbows are resacas. Resacas are larger than oxbows. They're distributaries, and the formation process is extremely different. It's not just a pointy-headed nerd academic like me saying, no, 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 that's the wrong word to use. It's a very different process. Rivers contribute together through tributaries and get bigger and bigger, and then as they reach their base flood elevation, distribute out into a triangle called a distributary. Look at the formation of an oxbow. Oxbow is a bend in the river, okay, where the river's meandering. It does happen in this area, hence the confusion, where the neck starts to erode because the water's flowing faster on this side, and this side starts to erode and cut and pinch, and then you got a bypass. Not the heart kind of bypass, the water kind of bypass, okay? But there it is. And then you have this bow-shaped, semicircular object that actually looks like something that you put over cattle or an ox so that that oxen can pull. And that's what I have found. I don't know. I never owned an ox. Yes?
So Jude, what would you tell a visitor to Brownsville from out of town? How would you describe it?
Good. That was actually my next slide's coming right up. But give me 1 second here to show. See all these little blue curves around the resacas? Those are classic oxbows.
Okay.
Every single resaca system, including the river, which I don't show here for purposes of, those are all the little oxbows and large oxbows around the river distributary system. This is why they know, and my eyebrow goes up, and they're like, and I look at them like, eh, and so they know now to get under my skin.
We should
Whatever.
really call it an ox yoke.
An ox yoke. There you go. Absolutely.
Yoke is the correct term.
You're right. You're right. I don't understand. This is what I'm told, and I don't know exactly the history. But oxbows, here's another issue. Oxbows are present throughout rivers around the world. Distributaries like this, and some of you may have read in the Herald that they quoted the Army Corps of Engineers, which actually quoted from my wife's report, which she just left because the kids were getting like bored. And she didn't say this. I know she didn't say this. I helped write the report too. That we claimed that these were the last remaining resacas in the world. Nobody has said this, and that is absolutely untrue. Okay? It's like somebody saying these are the last oxbows in the world. They're distributaries of rivers all around the world. What is relatively unique is a delta, the type of delta we have, without getting the details, and a relatively young delta system that has not been inundated and doesn't have a very wet river that erases its past. This is etched in the history of the history of the river is etched in the land, and we can still see it. That's relatively unique. That doesn't happen very often. How often? I can't answer that question because we don't study this. It takes a lot of money to figure this out, and we need a lot of remotely sensed data, but we're getting there. My best guess is there's probably 3 to 5 delta systems in the world that have this, and one of them is the Nile. The Nile is very similar to us, okay? Okay, very similar. A lot bigger river flow, but it's controlled just like the Rio Grande. And the delta system is wave dominated, just like ours. So, coming back to one of the questions about how we see this. This is LiDAR data. Actually, this is not quite LiDAR data yet. This is shuttle radar terrain mapping. We've done this for the whole world. The space shuttle, one of its missions, actually 7 of its missions, were to radar map the world with high resolution radar from space. And we've got 90-meter grid cell elevation points for the whole world. This opened up the door to hydrologic modeling, to terrain mapping for the whole world because it was equal information for all. It wasn't, we can't get that information because it's in Mexico, or we can't get that information because it's in the middle of Africa or somewhere where it just takes too much money to get to. Now, we observed this precious gem with one common instrument. One of the first times we'd ever done this, okay? Well, the first time we did it at the global scale. But, I'm sorry, the bottom is shuttle terrain. You see how it's kind of grainy? That's a 90 meter, every 90 meters in each direction you have a data point. See how fine this picture is up here? This is LiDAR data, where a plane flies over with a high resolution radar, or light, lasers, very low impact, right? You might say this is how I lost my hair, I stood underneath one too long, okay? Very low impact laser that's going back and forth and reading, okay, the return and getting a very high resolution. How high resolution? We can get a data point every foot in each direction, okay? That's billions, trillions of data points for the state of Texas. And you can imagine how much processing power it takes to start to, well, this LiDAR laser is not going to distinguish between a building or a tree leaf or a dog or my bald head or a car, and we have to analyze and start to get what we call true earth, bare earth. And we've gotten really good at sensing that. I'm going to show you some close-ups of this image here. Okay? This is now LiDAR. I have SRT in, but it is LiDAR data here. And you can start to see not only are there resacas and oxbows, but there's also more ancient resacas coming from these resacas. Do you see them? Right here, 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 right here. That is an old delta fan of Resaca de los Cuates. That's a delta within a delta. It happens all the time. We think it's about 12 to 15,000 years old. And these are actually, there's some names that are old from the USGS that I can't, well, in company, but it's recorded. Resaca de la Gringa is one of them, Gringa, okay? And another one is Resaca, I forget the other one. These actually have names in this area, okay? And you, yeah.
Can you
Yes, this is de los Fresnos. This is the Bayview Resaca or Resaca de los Cuates that goes through Los Fresnos and Bayview. Okay? This one is Rancho Viejo. Rancho Viejo, that's Rancho right there. This is de La Palma or de los Cuates. Okay? And this is Town Resaca. Yeah, way down here. Yeah. Mm-hmm. Yep. Anybody notice something interesting here? I'm gonna. Tara, tell me when I'm. Oh, she stepped out too. Anybody notice something interesting? Notice that this color here, this lighter color, here's the proof. It's higher than the brown color, the red rust brown color above it.
Oh, that is weird.
Okay. Again, those resacas are elevated. Okay. Remember, they are the boundary line. This is why, this right here is the Arroyo Colorado watershed divided by the Brownsville Resaca watershed.
The banks are elevated.
The banks are elevated, absolutely. I'm going to show you that here. Yep, exactly.
Banks of Resaca are the highest points in the
Absolutely. Yep. Come down to Brownsville. Cameron County drain ditch, number 1. If you live in Paseo de la Resaca, which is right here, this kind of man, kind of little picture here, a human-made resaca, okay, in an area where resaca doesn't belong. This is lower, significantly lower than the resacas on either side of it. Very different soil, high clay, high salt, can't grow the same kind of plants. Just like you can't put an animal in its wrong habitat, can't grow a plant in saline soil that's not accustomed to it. When they did this, and they said, why aren't the plants growing? Well, one reason is because it's salty. Now, it's beautiful, and it serves a purpose, but it's not a natural resaca. In fact, it's in between the resaca systems. And notice, this is an elevated bank on either side. That is an elevated bank. Storm surge can come ripping through about right here for a Category 5 storm, which we get every 50 to 75 years. Knock on wood, because has been about that long, okay? Since Beulah, 54 years now, okay? Yeah, and we're coming up on, we're due right now. That's not how probability works, but still, if you say, well, that's not too often, but let's say once every 100 years, even once every 100 years. This is 5,000 years old at least. That's 500 times. I'm sorry, 50 times. 50 times, okay? You're talking a lot. 50 times that this stuff has been inundated through by ocean water to several feet in depth. But it's about 7 to 10 feet, even with the most maximum storm surge once it gets to here. Remember these banks? They're about 10 to 20 feet high. So what are those resaca banks going to do to storm surge when it comes here? It's going to redirect it. This right here is the low pan that's created by repeated washing of storm surge over thousands of years and exposing the clays that are then blown by the southeasterly winds and form the clay dunes, the lomas, which you see right here. This is why, where you see Palo Alto battlefield, okay, right in this area right here, okay, very different terrain. You sense it, you feel it. If you're a naturalist and you walk around and you look and say, this is this saltwort and very different types of plants there than here. Why? Because this is riverine deposit. Our forefathers and foremothers who created and established Brownsville and Matamoros here did so for one very distinct reason. Why? Hmm?
Everything was green.
No? Well, yeah, it was green, but it's also
The richest soil.
higher.
Higher.
It's 30 feet higher from here to just here. Here you're 5 feet above sea level, maybe 10. Here you're 35, 40 feet above sea level. Why? Same story, folks. The river levees depositing, this is the most recent position, has not only deposited its banks, but the river's distributaries cutting through its elevated banks and deposited even higher. So we're here, And not here, because they knew even back then, long before LiDAR, the horse and the, we're going up. And not only that, they can read, like you said, they're probably more read the landscape. It's a very different landform. This is we know these trees don't grow in salt water. So we know this must not get as inundated as often. This is the safe place from those big huracans that come through on a regular basis.
So the highest place in Brownsville is right around town of South there.
Yep, exactly. Right west of here, right around where we are. Yep, absolutely. Now, this is a schematic on the natural levee. Okay? This is the river will flood its banks and leave deposits. The larger deposits closer, they fall out first because that water slows down and forms natural levees. So if you live on a resaca, not in a resaca, okay, and you can live in a resaca. It's funny, but remember the resaca is not always wet, okay? It's dry, and it's dry for a long, long time, and it's only about 5 to 10 feet lower. It's pretty attractive land. Let's build on it. That's what Matamoros did to a lot of their portions of their resaca systems. And we have done some to ours as well. And of course, you're in between those natural levees, and yeah, you're going to have an issue. But if you live right on the bank of the resaca, you're actually amongst some of the highest land in the area. And it's like running from a bear. You don't have to run faster than the bear, you just have to run faster than the person you're running with. You don't need to be the highest person in town, you just need to be higher than your neighbors. And that's what happens. This is exactly how it works. This is a picture. I'm very blessed to have found a great house about 16 years ago. My wife and I are finally going to pay it off here, I think, hopefully. And this is exaggerated, but this is how it works. Low, higher, lower. And it doesn't happen quite so fast. Okay? But that's exact. So rain that falls here is not going to run into the resaca. Unless we do what? Put a pipe underneath it. Storm sewers. So now you have a river system, an ancient river system, a waterway that is no longer connected to the river, which means it doesn't get floodwater and flushing on a regular basis. Only collects rainwater that falls in between its natural levees, and you add the vast majority of the water that's being added to the resaca systems, which are no longer really flowing. They're kind of more series of natural straight lakes that are stepwise, okay, linear reservoirs. Storm sewers. Do we clean storm sewers? Water before it drains out? We don't have time. We got to get it out fast. So, debris, oil and gas, dog poop, cat poop, bird poop, hopefully not human poop, but some, right? And everything that's in our streets, everything that's in our yards, everything that gets blown by the wind goes through the storm sewers, gets deposited into a relatively stagnant water system, and then people say, why are our resacas so dirty? Why can't we clean them up? It starts by cleaning up the streets. It starts by cleaning up the area around it and getting more water through the resaca system, which means we got to pump. Now, I have a whole other talk that I'm not going to go into today that talks about the varied roles, the vital roles that resacas play. And if you're interested in that, I'm happy to get with folks. But they serve flood protection, raw water storage, and yes, I said that. Okay, I'm happen to be the chair of the Brownsville Public Utility Board this year, and we do sometimes have to get our water from resacas. And people go, ooh. It's like, well, do you think the river's clean and the resaca's not? I mean, it's like the bird's like, I'm there. Okay, now, it's the same water. And the river is the same method. The river is very flashy, often very low flow, high concentrations of materials in low volume water. Means you're going to have high concentrations of contaminants, potentially of concern, but usually salt, and some organics.
The resacas will be cleaner than the river because the river has stuff from Mexico.
It depends on what we call, it depends on what we call the residence time. How long is the water going to stay there? Now remember, the river still is flowing. It may not be flowing a lot, but at least it's moving. Some of these resacas don't move for a long period. Some of these residence times are weeks, months, okay? Whereas the river, it's a matter of hours to days, okay? So either way, it's not like you don't want, number one, it's not, it's a mucky bottom, right? The clay bottom of the bottom is usually anoxic, and it develops that methane sulfur smell, which is natural, but it happens to smell a lot like the methane and sulfur in our guts, because that's the way nature works in the absence of oxygen. And everybody says, why does the resaca smell like toilet water? Okay? And I said, nature never promised you a rose garden. It never said it's going to smell well. Just look at decomposition, folks, and that's what's happening. Things are decomposing, mostly leaf litter and material, but also dead fish and other things are decomposing in the absence of oxygen. That's going to create methane, which we cannot smell, and sulfur, hydrogen sulfide, rotten eggs, which we can smell. And so anyone who has stepped in any coastal area of the world, stepped in pluff mud and pulled their foot out and gone, whew, yeah, that's not a pleasant smell. Okay? These are stagnant, relatively stagnant water systems. Not all of them. Town Resaca and Resaca de la Guerra de la Palma, PUB is pumping water to the tune of several 100,000 cubic feet of water a week through those systems. Why? Because the city of Brownsville has its water right. And we don't use all of it yet. We use about 30% of it during normal days. That extra 70%, if we don't use it, you lose it. If we don't use it, it gets taken away. So we use it and we pump it through the resaca systems. Not for private landowners, not for anything else. Just to use it, push it through, and it actually serves a great purpose. It helps lower that residence time, clean out some of that water, kind of try to repeat the ancient process of flushing, but at a regular pass, okay, instead of every now and then coming, okay? Improve aesthetics, park areas, recreation, ecotourism, economic development. They're a scarce commodity in South Texas and not too frequent in the world as far as distributaries now that we maintain with water. How am I on time? What time is it? I'm sorry, I didn't bring my phone's in. 6:05. 6:05. Okay, I'll go about another 5-10 minutes and we'll wrap it up. Okay. Resacas are fragmented. They're broken up. They're ancient systems that really have no business having water in them on a regular basis. The river has divorced itself from them, okay? And there is no support, okay? Where does the water come from? Well, the water has to fall in between those narrow banks, okay? Remember, the surrounding area is not contributing runoff to these resacas, or through the storm sewer system, or through water being pumped. And because we have the good fortune, at least for now, of having enough excess water to put into these systems, we can maintain them with water even during drier periods. But that may change, and it may change relatively quickly. We don't know. The climate models are uncertain as to our future in this part of the world. Some say a little drier, some say a little wetter, okay? But all say just a tad bit warmer, and we're right on that cusp of where just a little bit more heat and a little less water means the soils start to bake out instead of staying as wet as they were. You take away the natural flooding of the river process when those storms do come, and that soil gets drier and drier. We start to run out of water in the Rio Grande. Our permanent resaca systems are gone. What does a resaca want to do without that water? It wants to go whatever any other water body wants to do when it's not replenishing water. The sediment accumulates and turns into a wetland and or marsh or bog or whatever you want to call it, okay? The differences are subtle, but for all intents and purposes, land. The landform is healing itself from this scar that the river cut through it so meanly and terribly. So we have resacas in different states, some that are maintained full, some that are periodically wet, some that are very dry. And I have a student that's actually identifying those. This is an example, a wonderful picture from Rancho, Resaca de Rancho Viejo, and water level control. Why? We use these systems as irrigation conveyance to get water to farmers that use that to grow crops. It's a lot cheaper than digging your own ditch. And it stores a heck of a lot of water. Plus, it enhances property values and habitat. It's a win-win-win. It really is. And it's a win-win-win that has been winning and winning and winning with a lot, not so much intervention in public dollars investment. It's all been driven by what can you do for me as far as irrigation, flood protection, and crops. Now we're starting to see things change. As urban displaces ag, we increase the water contamination stress on this because now we got stormwater, right? We're no longer, the irrigators would call when for water? Usually in the spring and early summer. That happens to coincide with the flooding season of the river. So the resacas didn't know any better. These resacas say, hey, I got more water flowing through me in the spring and summer. It's like a flood. I like this. Comfortable. Reminds me of home. So just by happenstance, the farmers and the irrigators have saved the resaca systems that still have water in them for over 100 years. Here's this is a water level control. Here's a picture of an ephemeral resaca. Just downstream from that, you get resacas that sometimes have water in them and sometimes don't. But you see that it's enough water to maintain a very healthy riparian or near water forest. And then you get one, this is a resaca. It's old and it's overgrown with invasive species, opportunistic cane that will come in, supplant, and you've got a C. The picture, the C that I showed you before, not A, not B, but C. Now you may not see the difference. It doesn't look like a waterway, but this is an ancient distributary of the Rio Grande. And the plants will know the difference because of the soil. You cut all that vegetation down and you take an aerial photo after it rains, the clay soils will hold that water longer and the water will evaporate and the salt, the whiteness of the salt crystals literally will show up different in an aerial photo. That's what you will see when you look at Google Earth and look at an old system where they have now come through in Mexico near La Jarita and El Perote. This is heading towards Monterrey. About halfway through, they dig an irrigation ditch through that. And you can see, it doesn't show up very well here. I invite you to come up to the screen later. Okay, but can you see that bend right there? Okay, and another one right here, and an old one right here. This is, you can see the scars of the meandering oxbows around the distributary system. Even thousands of years later, even after deforestation, even after many repeated years of agriculture, the soil still tells the story, even though it's flat. Now, I had a whole nother talk and a few slides about flooding because of the recent rains that recent wallop of a storm that fortunately was not as big as it could have been. And I hate to say it's better them than us or anybody else, but had that epicenter rainfall been 5 miles west, this area in downtown Brownsville would have gotten the heat of it instead. And we drained to the east, so everybody would have gotten it. I hate to say fortunately publicly because a lot of people got impacted. But when we say flooding on the streets, and I'm just going to pass through, I'm going to skip through all of these different things. I want to show something really quick. Everybody know about, does anybody, the flood protection system that protects us from riverine flooding? Y'all know about this system? We have a multi-million-dollar system that has been built over the last 100 years or so to protect Brownsville Matamoros primarily.
The levees?
Yeah, the levees, diversion dams, yeah, and our flood protection dams, okay? Not only are these major dams, okay, this one's Falcon, and we have Amistad up further, and then we have Gomez right here in Mexico. Okay, these major dams, okay, and they are big, hold water for drinking, but they also protect us from big river flooding. This cut the replenishment of the resacas because we hold that water back, and it's a necessity. We wouldn't be here without it. We also have levees along the river to help build on top of the natural levee and help contain the water that does come through here. And we also have diversion dams, smaller diversion dams, Retamal and Anzalduas, which diverts, during a flood, diverts water into the Banker floodway and the Arroyo Colorado, the main floodway, and the Arroyo floodway around Harlingen because of Beulah, okay? This is what failed right here, and Harlingen got it in Beulah the worst because of it. And diverts a lot of flood water away, and the same thing is done in Mexico by compact. This is Retamal, south of Huasica. This is designed to protect us because we are right up against the river.
Because they had to blow up the highway after building.
Yeah, they had to, yeah, they purposely, yeah, let some water out that was collecting. Yeah, so we have high dams, diversion dams, floodways, artificial levees as opposed to natural levees, a whole series of systems that have been there now for decades. We are fairly well protected from river flooding. Okay, I'll say that again. Doesn't mean it will eventually fail. I hope I'm not around when it does. Okay, but it will fail. All mechanical human-made systems fail, right? Something will fail. Parts of this have failed, but not the whole thing.
If we get 24 inches like Houston got, we're in
Yes and no. Hey, we actually do fairly darn well. Remember, again, depending on where you are and where you choose to live, and I understand that there's choices are sometimes limited, okay? But we've now gotten to the point where technology that I'm going to show you here, to a savvy and to somebody who says, all right, look, if I'm going to live here for 30 years and I'm going to invest and I have a choice, and they're I'm going to choose the higher land. I'm going to go to higher ground. We just didn't know that in the past, or we forgot it. We knew it and we forgot it, or people just purposely didn't tell. And that's not fair. Okay, this is an old schematic from the IBWC of their system, and it explains it. I invite you to look at it online. It's exactly what I showed you, okay, but in kind of a cartoon image, okay? And I've shown you this before. These are natural and main drain systems throughout the valley. We've got the Hidalgo main, the Willacy main, the Raymondville drain, the north. All of that drains McAllen and Edinburgh, up and around, repeating the same process. Don't go through the old system. Go up and around. What do you mean up north? North and around, north and around. And down here, we can't go north and around, okay, because of that big resacas system right here. So we just go straight east and toward to the south. Northeast or east. Get that water out to the ship channel, to the laguna. But during a hurricane, the laguna and the coast, those waters will be up, storm surge. You got storm surge coming here. All of these systems don't drain as well. And the channels, they start to back up. As a hydrologist, I'm not a politician, and PUB is not in charge of storm drainage. Thank God. I can tell you right now, there ain't jack squat we can do about it. It's like asking the Northeast not to have snow on them during a blizzard. It's like asking California not to shake during an earthquake. It's like asking the Sahara not to be dry. We live in a delta.
Well, it's like South Padre Island.
Flood happens.
They drain through the bay.
Yeah.
But if
The bay's up, it's up. Yeah, flood happens. Now, we can build smarter, and we can invest in systems that will protect us for a little bit longer. And there is a lot of stuff we can improve, don't get me wrong. But the poor politicians that get hammered every time it rains saying, ¿por qué? Why is this still happening? It's still happening because it's been happening for thousands of years, and now we're all here. And we made it worse by covering up the soil. Of course it's gonna rain. This is the way we flood, or we drain kind of in the Brownsville area. These big, all heading to the ship channel now, okay? Because that's the coastal water we want to get to. I want to skip through some of these photos really quick. We're low gradient, we're a coastal basin, we have an old, unverified storm sewer system, okay? We made these systems long before it was easy, well, long before computers, so we had maps. Those maps, many of those maps are gone. Identifying just where the heck the pipes are. The condition of the pipes that are about 6 feet under, that haven't been looked at or crawled through in ages, that have collapsed, some of them. This is really expensive stuff to fix. We get the storm drainage system we're willing to pay for. And that's not easy for a politician to say. But I think we're finally getting there, because you want the streets not to carry water at any point in time?
yeah.
I'll take your money as an engineering consultant, happily. And boy, there's a lot of money in flood right now, okay? But I'm one of the first that will tell folks, I'll do the study, but you ain't gonna like the answer. And they still tell us, do the study because we need the cover. Okay, off to the races. What can we do? What can we do? Smart growth. Work within our means. You live within your means financially, you gotta live within your means here. And Brownsville's done a much better job, just by circumstance, on this location of the bend of the river than Matamoros. Matamoros' urban density is 10 times ours. and you know how they flood. I mean, it's a fact of life there for water in the buildings up to 3 feet every few years. Last slides here. This is no, it's a river. It's a street river. Okay, that's what it is. And somebody trying to make it through. We use computer models and stuff. It's, the nerdy technical stuff that I do, blend in a whole bunch of information. I'll tell you right now, a lot of times it's like a dart with closed eyes and a dartboard, okay? Because we don't have a lot of sensors out there, and those cost money that prove our computer model is right. And I have to say that. This is our best guess. But our best guesses are better than a blind guess. And we have developed, this is going to take a second to show up. We've developed live computer models that can tell us, hey, this is what a 100-year storm, a 1% chance a year storm is going to look like in downtown Brownsville. What streets are going to flood? And does anybody see an interesting pattern right here? What does that look like? It looks like an Oaxaca. Who said that? Yeah, an Oaxaca. Absolutely right. It's an oxbow. It just got built in because they only happen to be 2 feet shorter or lower. Our police station is right here. Go by the Brownsville police station and drive through 7th and Madison, just right up the street here, and you will see that the police station, if you're standing on the road and the curb right there, the police station ground is right here. By design. All of downtown Brownsville was built that way, even long before. Not only did they go to the high ground, but they said, we need higher ground between us. We're going to dig the streets down, build the blocks up like they do in all the places around the world, because we need water to flow through the streets. We don't want it in our houses. The problem is that those streets aren't perfectly flat, and they're not perfectly sloped, and we can't build a storm sewer system too sloped, because we get into groundwater and then we get too low. We're below sea level. We got to pump that water up. And we can't build the pipes too big because we don't have the money for it. So even with a storm sewer system, oh, by the way, this is a really cool picture. This is my grad student a few years back.
And in order to cope with the increased amounts of rain, the pipes have to be bigger. So
Yeah.
that's more money.
Even more money.
So
Yeah.
where do you come balancing that?
Yep, exactly. This is a bad storm. This is what we would have seen had the storm been twice as long and about as intense, but instead of over South, over Brownsville, over downtown Brownsville. Probably a little bit less, not quite as bad, but all those streets would have been flooded.
What's
And
that? Is the yellow the highway?
the yellow is Town Resaca. Town Resaca, yep. And that happens to coincide with the highway, because they built the highway on the Resaca 50 years ago. They filled it up. The Resaca goes under the highway. Right here, focus on that little area right there, and that is, oops, you can see Washington, is it Washington Park? What's the park that's right now?
Yeah.
Yeah, okay. That's right there, blown up, okay? Okay, and I'm not saying, this is not precise and accurate enough to say that little blue dot means that house is flooded. That by no circumstance. But what it does mean is that you can see very clearly that these streets are going to flood. You can see the oxbow right here. So much so that during that event, I happened to be driving around. My grad student who was at the National Water Center called me while it was raining. He said, take some video at Madison and 7th, because they had just released this model, and that's Madison and 7th right there. Meanwhile, we drove right up there in the same storm system right here, just a few minutes later, and no street flooding yet. Actually, it didn't street flood there. That little intersection got flooded. Why? Because you're 2 feet higher. So tell me again, we're perfectly flat. We're not. That's going to take a second. We have a very extensive storm sewer system underneath us right here, right now, this moment. But these were students from around the nation, some really, a lot of students that were much smarter than I am, okay? Working for the National Water Center, and I brought this problem over to them, not the Weather Center, the Water Center, which is actually dealing with flooding right now, in Tuscaloosa, Alabama, University of Alabama, okay? And beautiful federal building, must have cost a fortune. A good senator, they had a senator that brought a lot of what are those called? Money on the side there. And they helped model a storm sewer system at best guess, okay, and then try to model the effects of the storm sewer system, okay, showing which way they flow and everything else, and said, guess what? In flat terrain, and we're publishing a paper on this, in flat terrain, in an urbanized setting, storm sewer systems, which are designed to carry 2 to 5 year storm events without street flooding, can't even do that. About a 1 year event. So you get a 5-year event, the vast majority of that water has to go through the streets. You get a 50-year event, all bets are off. It's like the storm sewer system isn't even there. It can't take that water. There's no way. People say, well, dig a big hole in the ground. 10 feet below us, we got salt water. So you're gonna have to dig a big vault in the ground, and there's no way we can afford that option. It's not feasible. This is basically saying here, there's no real change. It's all about the same, and a very small percent. During a very intense storm, we're talking about 2% to 3% of the water's gonna go through the storm sewer system. In a longer event, over time, maybe 10 to 15% at max for a 5-year event. It's not moving that water. You can't. This is how sensitive, basically just showing for different, and these areas that turn black and white basically show the reduced capability of the storm sewers as the event gets stronger. But again, you can see old oxbows and low-lying areas. Folks that live downtown know whether they're high or low simply because how often their streets get flooded.
So if we use the West Rail Trail
Yes.
as a ditch
Mm-hmm.
to get the water towards the river and then use it like in Powell Pump Station up in the river, that would alleviate some of the flooding along there.
Well, yes, the catch here, we've got two, yeah, you're absolutely right. We've got two options. Don't worry about these changing colors. You either get over the levee into the river or through the levee into the river, but remember, the river is not always low. Or you get to the resaca, okay? And right now, the system's designed, if you're about here, you go through these old oxbows, like here by ITEC, that can hold some of that water. But we built a federal levee right here to protect us from the river. Well, the federal levee doesn't only protect us from the river, it prevents water from flowing that way. So now all the water has to go to town Resaca, and it has to come all the way down through here, out to join another drain, the North Main drain, and work its way to the ship channel. And all of this has to be maintained, cleaned, and efficient water movement. And you're talking a system that again, we get the storm drain system we're willing to pay for. Okay, real quick, if you haven't, I'm going to show you Tara, I'll get you this information. This is a wonderful website that you can interact with elevation. Okay, and you just choose the square you want to see, and it will change the scale. Okay, and this shows the valley. You can see the first mountain footholds up heading towards Monterrey. You can see the same mountain range up here by. And I always tell my students, you want to see mountains in the valley, just drive to Rio Grande City and head towards Falcon Lake and look southwest and see the Sierra Madres off. And I saw that as a kid because my grandparents lived in Laredo. And my dad, I remember one of the stories was, look, you can see mountains. And I'll never forget it. And on a clear day, you can see the mountain range on the horizon from the valley. Okay? But you can see the cut through the higher green, the higher reds, the green, the river, floodplain itself. And then you got the coastal low-lying blues that are in the 10, 15 meter. I want to zoom in real quick into Brownsville, and you can start to see. This is why Brownsville and Matamoros, green is higher than blue. 10, 12, 14 meters instead of 2, 3, 4 meters. This is why we built here, not here. And by the way, you see all these little green and yellow, those are old resaca systems, old distributary systems, ancient systems. What? I'm sorry? I gotta look. I forgot. It's elevation. I got it. I'll pick it up right here for you in a second. I forgot to put it in here. And one last picture. It's my last slide. This now, the color scheme's changed a little bit. Reds are high, yellows, greens, blues are lower. Again, even here you can see the elevated resaca systems, the low-lying areas between the resacas, elevated Brownsville and Matamoros, and the low area around it. This is not steep. This is not obvious to somebody who is looking at it from a plane or driving down it through a car very quickly. But if you walk it, you'll sense it. And if you pay attention to the flora, you'll see it. That's it. Questions?